Module 2, Lesson 15, Interpreting Residuals from a Line. We're going to use the best fit line to make predictions about other data points, and we're going to use the residual line to determine the accuracy of the predictions based on the best fit line. Open your workbook to page 95. All right, calculating prediction errors. Remember, that's what the residual is, the prediction error. The gestation time for an animal is the typical duration between the conception and the birth. The longevity of an animal is the typical lifespan for the animal. Okay, so we have gestation period right here. That's how many days the animal took until it was born. It says from conception to birth. And then longevity, that's this one right here. That's how long in years that the animal was alive. So the gestation time in days and the longevity in years of 13 different animals are shown in this table. I got the baboon, the black bear, the beaver, the black bison, the cat, the chimpanzee, the cow, the dog, the red fox, the goat, the lion, the sheep, and the wolf. So we're going to compare how long it took before they were born, basis how long they were here on Earth. And these are just averages. Here's the scatter plot for that data, along with the best fit line. You'll notice it's scattered, but it has kind of a positive trend. Okay, finding the equation of, and it says least squares model, or least squares line. And remember, least squares line is the same idea as saying the best fit line. Relating longevity to gestation time for these types of animals provides the equation to predict longevity. How good is this line? In other words, if you were given the gestation time for another type of animal not included in the original list, how accurate would the least squares line be for predicting the longevity of this type of animal? Okay, using the graphing calculator, verify the equation of the least squares line is y equals 6.642 plus 0.03974x. Okay, so what they're saying by using the graphing calculator to verify the equation, that just means put all of the points in and see if we get this equation. Okay, so that would mean you'd have to put all those points in your stat and then do the stat calculate and get that equation. Okay, so there's our line again with our scatter plot. X stands for the gestation time and Y represents the longevity. Okay, so here's our X, the gestation time, and here's our Y, the longevity. So suppose a particular animal has a gestation time of 200 days. If we look back here, 200 days is not in the table that we were given. So we're looking at an animal that's not already on the table of data. So suppose an animal has a gestation time of 200 days. Gestation is our X, so that's telling us that X is equal to 200. It says approximately what value does the line predict for the longevity of this animal? So that means we're going to take the equation, we're going to plug 200 in for X. And so the equation was Y equals 6.642 plus 0.0397 4 times X. And I'm plugging in for X 200. And then I'm going to calculate that and see what that comes out to be, and that'll give me their lifespan. Y is the longevity, lifespan longevity. Okay, so I'm plugging that in my calculator. And I'm getting 14.59, so a little over 14 and a half years. Okay, it says would the value, number 3, would the value you predicted in exercise 2 necessarily be the exact value for the longevity? Could the actual longevity of this animal be longer than predicted, or could it be shorter? So first of all, no, it wouldn't necessarily be the exact value. It's going to be an approximate value. And the actual could be longer or shorter. Okay. Oops. Sure we got everything. Yes. All right. It says you can investigate further by looking at the types of animals included in the original data set. Take the lion, for example. Its gestation time is 100 days. You also know that its longevity is 15 years. But what does the least squares line, remember least squares line means the same thing as best fit line. Keep using this new vocabulary on us, but it means the same thing that we've already been talking about. So what does the least squares line predict for the lion's longevity? So that just means that we would take 100 and substitute it into the equation, which they did right here. Took the equation y equals, substituted in 100, and they got 10.6. Okay, so for the lion, the actual, they said it's 15, but the predicted is coming out to 10.6. Number 4 says, how close is this to being correct? More precisely, how much do you have to add to 10.6 to find the lion's true longevity of 15? So how close is it to being correct? Let's take 15 and subtract 10.6 from it and find out how far off that is. So 15 minus 10.6, and that's 4.4. Okay, so how close is it to being correct? It's 4.4 years off. So that's how much we would have to add onto the predicted value to get the actual value. It says you can show the prediction error of 4.4 years on the graph like this. So the line, the best fit line, notice that the lion's actual is right here. And then the lion's predicted would be right here. So that's the lion's predicted. And the reason why that's predicted is because it falls on the line right below where the line's actual is. And then the distance from the lion's actual to the lion's predicted would be a distance of 4.4. That distance is what we call the how far off it is, and that's actually what we call the residual, which is what we talked a little bit about yesterday. Okay, let's continue to think about the gestation time and the longevity of the animals. Let's specifically investigate how accurate the least squares line predicts the longevity of the black bear. Okay, so we're looking specifically at the black bear. It says, what is the gestation time for the black bear? So let's go back and look that up on the table. The gestation time for the black bear is 219. Okay, so gestation time for the black bear, and that would be our X, is 219. And then it says, look at the graph. Roughly, what does the least squares line predict for the longevity of the black bear? So if I look at the looking at the graph, sorry. I'm back to new pages here. Oh, I think I'm still back to new pages. There we go. So the black bear was at 219. So this would be 225. So 219 is going to be before that. So I'm thinking this point right here is the black bear. So if I were to go straight down, it says approximately where does that line look like it's at? It looks like it's between, or it looks like it's roughly at about 15. That's my rough estimate. So I'm going to say about 15. Okay, now the next question says use the gestation time from part A and the least squares line and plug it in. Okay, so we're going to find out more exact what that answer is. So 6.642 plus 0.03974, and we're going to plug in the 219. And find out what that should be coming out to. I'm saying about 15. Let's see how close my guess was. Okay, so 6.642 plus 0.03974 times 219. And it's 15.34, so it's a little higher. So it's coming out to y equals 15.34, and that would be years. Okay, now they're asking us what is the actual, so we can go back to the table and we can look at the actual. Okay, and the actual is actually 18. And now it says how much do we have to add to the predicted value to get the actual. So let's see how far off it is. So 18 subtract 15.34. And that's 2.66. So that's how far off it's 5. It says show your answer on part F. It says show your answer on the graph as a vertical line. So just like the other one was. And that's the line I just drew here. So this would be the 2.66, how far off it is. Okay, we're going to repeat the activity now for the sheep. Okay, so looking specifically at the sheep now. Substitute the sheep's gestation time for X in the equation. So let's go back and look at the sheep's gestation time. I'm going back to the table. And I want to look specifically at the sheep. The sheep's down here at 154. So let's plug that one in. Okay, so X is 154 this time. And I'm going to sub that into my equation. And the equation was Y equals 6.642 plus 0.03974 X, except for I'm going to plug in for X, 154. And see what I get. And I'm getting 12.76. Says, what do you have to add to the predicted value in order to get the actual value for the sheeps? Okay, so this time, let's go back and see what the sheep's actual is. I think it was 12. Yep, it's 12. Okay, the table doesn't hint that this time it should come out to be negative. And that's because if we keep subtracting it the same way that we've been subtracting, I've been taking think about how we did the work yesterday. I subtracted 18, which is what the actual was, and then subtracted the predicted value. So if I do that the same way here, the actual is 12, and I subtract the predicted 12.76, since I'm subtracting a bigger number, I'm going to get a negative number this time. And that's negative 0.76. So this one's a little less than a year off, and it's negative. And the reason why this one's negative is because this time the predicted value is coming out a little bit too high. Okay, it says show your answer for part B on the graph with the vertical line. And then it says write a sentence describing the points in the graph for which the negative number would need to be added in order to get the value. So if we go back to our graph here. Let's see. Oops, went too far. There we go. Okay, so he was 154. So just a little bit here, 154 and 12. So that would be this point right here for the block there. Or no, this was the sheep. So it's this point right here is the sheep's point. And then the point's right above it, right here, and that was only off by negative 0.76. And you see the difference between that point and the other ones? This one's below it, which is why it's coming out to be negative. Okay, so it says show it on the graph, which we did, and then it's write a sentence describing in the graph for which a negative number would need to be added. So all of the points the line, below the best fit line. Would need a negative number to be added. Okay, so continuing our discussion about residuals and prediction errors. So in the previous exercise, you found out how much needs to be added to the predicted value to find the true value or the actual value of the animal's longevity. In order to find this, you have been calculating actual value minus predicted value. This quantity is referred to as the residual, which is exactly what we were doing on yesterday's lesson. Okay, so the residual is the actual value minus the predicted value. It's summarized as, whoops, I didn't even realize that it's right there. Okay, so it's summarized as the residual is equal to the actual y value minus the predicted y value. Okay, so here is the table actually all completely worked out, showing us the residuals for all of the animals. So you can see which ones have positives and which ones have negatives. The residuals show the actual longevity of an animal should be within 6 years of the longevity predicted by the least squares line. Okay, so if you look at all of these, the highest positive value, or highest, let's see, negative value. Yeah, highest positive value is right here, 5.9 years, and the smallest negative value is negative 5.8. So that's why they're saying that it should be within 6 years. So there should be, for this line, the answers are always going to be within 6 years of what the actual value is. It says, suppose you selected a type of animal that's not included in the original set of data, and the gestation for the type of animal is 270. Substituting x is equal to 270 in the least squares line, you would get 17.4. The predicted longevity is 17.4 years. Think about what the actual longevity of this type of animal might be. Could it be 30 years? How about 5 years? Okay, well, according to the error that line has, at most it's going to be off by 6 years. So if we go back and we find out that the line or the predicted value is 17.4 years, sorry, spelled that wrong. The actual could be as much as 17.4 plus 6, which that comes out to 23.6 years. Or as small as 17.4 minus 6. So that's when you find out what the error can be, then that tells you from now on when you work with anything that has to do with this equation, then this equation is good for things in telling us that this is all the error that it's going to have. See, 17.4 minus 6 is 11.4. Okay, so this number right here, this is as much as it's going to be. And This is as small as it's going to be. So they asked us, could it be 30 years or could it be 5 years? And the answer is no. The actual can't be 30 or 5 years. Because the most it's going to be is 23, and the least it's going to be is about 11 years. Judging by the size of the residuals in our table, number 8, what kind of values do you think would be reasonable for the longevity of this animal? Okay, so I just did the word. This, the animal would be between 11 to 23 years. Okay, because it could only go as much as 6 more than what we had calculated it to be, or 6 less than what it was calculated to be. Okay, exercises 9 through 10. Continue to think about the gestation times and longevity of the animal. The gestation time for the animal, for this type of animal, is called an ocelot, and it's known to be 85 days. The least squares line predicts the longevity of the ocelot to be 10 years. Okay, so plugging in 85, they got 10. Based on the residuals in example 3, would you be surprised to find out that the ocelot was 2 years? Why or why not? Might that be a sensible range for an actual longevity of an ocelot? Okay, so based on our work, yeah, I would be surprised, because using the idea of the 10 plus 6 years and 10 minus 6 years, that actually gives me 16 to 4. That should probably be written the other way around. So 2 years is out of that range. Okay, so yes, that would be surprising. Okay, we know that the actual longevity of the ocelot is 9 years. What is the residual for the ocelot? Okay, so if the actual is 9 years, and we had calculated it to be 10, then the residual is the actual 9 minus 10, residual is -1. So remember, for residual, you do the actual minus the predicted, which was 10, so the residual is -1. Okay, and that's it for today's lesson.